everyone. Thanks for joining us with this session. I really like the last session of the last day. Okay, it's very relaxed. I'm Eric from NVIDIA. I'm working on diagnostic and firmware.
Yeah, I'm Sivagar. I'm working on the Google manufacturing SDK stack, basically end-to-end software things. So this is basically, we presented it 2 years back around this time. Google, the manufacturing SDK, how we work with various vendors and others. This is mainly for like a co-development on with the other partners. So here I'm just going to give the lessons learned in the last 2 years. And I'm also have Eric with me, who actually was journey with us in some of the cases, and make his point of like what are the different things we learned. Go ahead, Eric.
Okay. So to know the challenge we faced in the past 2 years, I think you need to understand the process from the factory testing to the data center deployment. A server is being built in the factory, and it will be installed with diagnostic OS and running some. It will be installed with manufacturing OS and run diagnostic. And if it passes, it will ship to the data center. Then in data center, once they receive the system, they will install the production OS, then run the diagnostic testing, and if it's passed, then it will be deployed. Then everyone is happy. But the thing is, there is an unhappy path. The tricky part is there are 2 OS in this process. One is the manufacturing OS, the other is the production OS. So the manufacturing OS, the purpose is to do the hardware validation. So on the security, it's more relaxed or even disabled. And on the kernel and driver, it usually it's up to date. And some feature of the kernel and driver will be enabled to help the validation and debugging. So besides, there are also many tools being installed in the manufacturing OS. But compared with the production OS, the purpose is to serve the customer workload. And so it needs to be secure and stable. And so the update of the kernel and driver would not be so quick. Hence and besides, the tools is not so diverse. So that's the problem. So these 2 OS is different in nature. So think about one thing. A test is passed in manufacturing OS, but it doesn't mean it will be passed in the production OS. So and you can think about one thing that, let's debug that. But the thing is, there are 2 cases. One is, if the issue happens in the factory, some partner like NVIDIA can provide a better support. But if it happened in the data center, because of the restriction of security, we are not able to provide prompt support. And the worst is when we go to the data center landing, it's very close to the production. So the pressure will be getting higher. So that would be a problem. So think about one thing, how do we mitigate this? So some people started to think that maybe we should make the manufacturing OS as close as possible to the production OS. And so there is a high chance that we can find out issue early and fix in the factory to avoid the problem. It seems that it's happy ending, everyone is happy, but actually it's not. Here's the reason I would say from NVIDIA perspective. You can see this, that in NVIDIA, for example, on GB200, when we do the our product, for example, the GB200, we have our own OS, so we will do the patch. We will install the OS, we will do the validation using our OS. But let's say one of our CSP asking us to support their OS, and NVIDIA has to spend extra effort on this. Let's say we have end customers asking this. That means that we need to support the N+1 validation on this. So it's not scalable to us. No company has unlimited resource. Same to NVIDIA. The worst is, with limited resource, we are not able to make everyone happy. So the thing is, we need to shuffle the resource to support this. And if engineer is being contacted, it will getting worse. So it's not a win-win. So eventually, it could be it's still slow down things. So I think today we want to. Later, I will hand off to Sivagar to share what Google have today. And the goal of this is we are hoping to have more open conversation with the industry. If there is a better way that we can do a win-win solution to everyone.
Yeah. Thank you, Eric. So Eric actually pointed out the different things, right? So main thing is like when you go into code development. So here the code development, like it's the same thing what Eric was talking about. So we get the things from different folks, right? So the very good example would be here, right? So we work with CPU partners, NIC partners, SSD, various things come into the system. At the end, we deliver it to the data center. And we wanted to be validated all these things with the co-develop with the relevant partners. And again, like Eric mentioned, everybody have their own operating systems, our own way of doing things, right? And then there is like discrepancy all that. So the way we started like a couple of years back is like, okay, how we can address this? So one of the things is like, okay, what we need is a framework, right, to deliver all this thing. So we created a Linux distro based on Yocto. I'll talk about it, why Yocto later. And then what we need is a manufacturing test and tools. So we follow OCP DIAX, so Google did participate in all of this, right? So on the DIAX side, we have some framework, at least like we can develop DIAX and tools on this one. Then there's the Yocto. And right now we have like 20 plus partners we working since 2020. And we have like various distros. So basically we create multiple distros. I'll tell you why. And then we do support 3 long-term LTS Linux versions, right? And they are continuously integrated, validated, and deployed. So the way it works is basically we have our server SDK, we work with CPU partner, NIC partner, and the SSDs. They validate based on this SDK. And with the tools and DIAX, we commonly develop. And then we share those with our JDMs who actually build the system. And then it's a L6, L10 process. They validate those with the manufacturing. Then they will land the system to our data center, right? So this is the overall vision. So everybody have the same stack. So we can, if there is a problem, we can use the same software stack, DIAX, work with relevant partners to solve the problems. But there are some challenges, right? So number one is the licensing and compliance. So for example, there are like various things. So there might be like early product embargoes or partner IP. So we cannot just share everything with everybody, right? So how we handle this one, right? So, and then we have to create the right version of software for each folks, right? While working through licensing and compliance. So for that, Yocto actually helps. It has a better solution, right? So it has layers. It has different templates. You have the Yocto model is basically like BSP and other things. It's created for embedded environment, but we found that it's very much work perfectly for our server level things, right? And based on, so you can design, have different version of kernel at the same time, and then you can have like product specific layers and different things. And based on who is developing, so let's say JDM A is developing with NIC 1 and then CPU A, then we can just create those layers for them, enable them, so they can build a Yocto image, basically the Pokey image, and then they can run their distro on their side. And also the kernel, like we have here, there could be a multiple version of kernels. Again, the kernel patches, drivers, all those are based on what the JDM or we have the licensing things with, right? So this helps us a lot in terms of like, we have like 50 plus distros at the time, and then we can work with multiple partners. But again, it creates different problems, right? So like this is basically like why we use Yocto. So like I said, it's create the separate layers, and it's easy to build distro. And again, we can use whichever Linux tree we want, right? For example, I can change with one line in Yocto code. I can use upstream Linux, or I can change it back to the one internal we have, right? Or the ones we shared with some other partner. So that actually helps us easy to use. And the major thing is like you can build the same thing with multiple architecture, whether it's Intel, AMD, or ARM. We can build them with the same tooling, basically, right? And it has extensive online community support and documents and everything. So like I mentioned, so it fits our goal on like working with multiple partners and multiple folks at the same time. But it does have challenges, right? So that's what we found. Number one, it's a new language to learn, new infrastructure to learn, right? So there is a learning curve. Like I mentioned, so you can overcome, we use, online documentation and the community. You can find always solution for the things you want to do because it's a wider audience there. And the default libraries and tool versions are dependent on Yocto versions. So that means if, let's say, you're using Yocto like Pokey 4.0, it comes with certain things, and 5 might have like 6.6, so you might lose some of the older kernel support, and some of the tools might be different, so you might need to backport, all those things there. But it is, like I said, like with the open community, there are patches, you can always find something backport easier for the old infrastructure and things like that. And tool update requires distro rebuild. Like I said, because we want to, to make sure that the licensing and compliance are properly met. So we have to ask the rebuild the whole thing. Like for example, like let's say you missed one tool in that one. So you might want to go back to the Yocto and enable the tool you need, right? So that actually sometimes creates a lot of things, and it takes a longer time to rebuild. So one example is like, let's say in the manufacturing, we release a binary, and then they find some issue. They needed some tool, which is not immediately available in the distro. Then they need to get it. But if it's in, let's say, commercial OS, you might just connect to the network, apt-get, and you get that one, right? So here you have to rebuild that image, right? So it takes some time. And we also overcome that with like supporting Debian packages, so you can download it, but still you need to build it to get that one into it. So that's one of the things. And again, like I mentioned the previous one, like public distros have better tooling and support model, right? So you can use Ubuntu, you get apt-get, you get whatever you want. So again, but to keep the public distro, you need to have additional requirement, additional resources. It's not as simple as keeping the Yocto. And so that's the lessons we learn. So like Eric mentioned, so we also agree like we need some common like an open standard or open methodology for everybody to work together, right? So if you are a manufacturer co-developing with multiple customers or deploy like multiple SKUs, multiple manufacturers, then if you think this solution, like Yocto-based solution, what we are discussing, is really helpful, right? So reach out to us, and then let's see if we need a OCP level server manufacturing SDK, and we can work together on that one. Yeah. Any questions? Any last minute thing you want to add?
No, I don't have much to add, but I think it's a good idea to open this and to have a more open conversation on this, because I think we need a win-win solution for everyone. And so as you saw in the previous slide, Sometimes it's good for the hyperscaler, but it's not good for the partner, the vendor partner. So someone like NVIDIA, and even other partner is the same. It's too much effort. And also you can think of that. If there are multiple OS, we validate on the same hardware for the multiple OS. And actually the hardware is working, but because we need to integrate into different hyperscaler. So this is a double effort. And so it's better we have a better way that everyone get a win-win instead of putting effort on any one of the ecosystem.
Thank you.
Thank you.